Topic 3-1, dividing monomials. This can be referenced in our Holt textbook, Chapter 7, Section 4, on page 467. And on page 446b, they're the properties of exponents put all together with all the different power properties that, if you forget, you can refer to on that page too. So I should go ahead and put that on here, that it's also on page 446b. So that's just a reference page. Okay, let's look at the first one. If you've got x to the power of 5 over x to the power of 3, that's like having 5 x's in your numerator and 3 x's in your denominator. If you cross out like terms, you're left with 2. So what you can see is that with your exponent powers, you're subtracting. So again, this is 2 on top, 6 x's on the denominator. You'll be left with 4 on below the division sign. So if you can think of this as subtraction, I'm going to put that here too. But remember, when you subtract 2 minus 6, that's like saying 2, change this to the opposite, plus a negative, so that that equals to a negative 4. So x to the negative 4 would be written like this. Okay, so the rule is when dividing and bases are the same, subtract the exponents and put the result where the larger exponent is. So to highlight the word when you're writing this in, just make sure you're remembering that you're subtracting your exponents in division. So let's look at a few of them. You've got 5 exponents on top, 7 in the denominator. So if you want to visualize it, write out 5 and 7 on the denominator, you're going to be left with 2. To simplify this further, you want to take 10 to the second power, which is not 10 times 2, it's 10 times 10, which is 100. When you have a problem like this, you actually do the division of your whole numbers, and then your two ends are going to cross out. So this one, the variables went away. All right, number 3. You've got powers of 10 shown here. But 12 divided by 4 can reduce to 3. And remember, that's in your numerator. 6 minus 3 is 3, so your 10 becomes a power, stay with the power of 10. So 3 times 10 to the power of 3 is 3,000. Here, 9/12 can be reduced to 3/4. You got 4 y's, and this is understood to be a 1, so 4 minus 1, you're left with 3. All right. When you divide a -7 divided by 28, you get 1/4. They don't normally put the 1, but if you feel more comfortable with a placeholder, then you can do that. There's 2 a's in your numerator, 1 in the denominator, so you're left with 1 left over. You have 3 b's in the numerator, 1 in the denominator, so you subtract and get 2. And the c has nothing common with it in the numerator, so you will leave it in the denominator. So just do this in steps, your whole numbers first. Because these are both negatives, they reduce to a fraction 3/5 that become positive. R, subtract from 1r, would give you an r in the numerator. But if you've got 1 subtract 2, and that's like saying 1 plus a -2, that leaves you with a -1. So s to a -1 puts that in, your s in the denominator. So just remember, when you have your base to a negative power, it's in the opposite placement of where it would start. Right now you're still dealing with them going to end up in your denominator, but we'll talk later when it's actually negative in the numerator. you would end up having to place it in the denominator. Okay, numbers 7 and 8. Look carefully. This 4 has to be taken, the 3 to the power of 4 and the s to a power of 4. So if you look at this, your s's are going to go away because s to the power of 4, s to the power of 4, both in your numerator and your denominator, end up removing completely. But 3 to the power of 4, again, I want you to remember you're looking at, let's just put that in the calculator. You've got 3, use this house top for finding powers. House top 4 is 81. You're then going to divide that 81 by the 3. That's where they got 27. But because your s's cancel out, your final answer is just 27. Okay, this one looks like a long, drawn-out problem, but just be careful that you have a negative 1 to the power of 7. If I put negative 1 to the power of 7, I'm going to get a negative 1. But be careful, if you put negative 1 to the power of 2, this is just an example, you're getting a negative 1, but that's actually wrong. You would want to say it's a negative 1 times a negative 1, which is actually a positive 1. So when you are doing even exponents, you want to make sure to remember to put it in parentheses. So when in doubt, always put it in parentheses, because your answer is actually 2 negatives make a positive. That happens to be an odd number, so you're okay there. But here, because it's a negative 1 with an a to the 6, not in if it's not shown to be in parentheses, then that power only takes the base of a, not the negative a negative 1, which is understood. Where in this case, the 7 did take this as negative 1, 7 times. This, however, is just the a. So if there's 7 on top and 6 on the bottom, that, oh, I'm sorry, the a's go to just 1, and then the 7b has to stay because there is no matching denominator. Okay, pause it and take these notes if you need to, but let's go on to a couple more problems of review. This is a little bit of review of some of the algebra in previous units. So let's look at this one. You're going to first distribute 2 to the x and 2 times 3. And on this side of the equal sign, same thing. That's a negative 1 that needs to be distributed with the 4x and the negative 2. Therefore, making the 4x negative, and a negative 1 times a negative 2 is a positive 2. So again, if it helps, draw a line through your equal signs. You want to combine like terms. The 2x on this side of the equal sign doesn't have anything, but these two have to be combined to get this before doing any kind of movement across the equal sign. Same thing over here. This is a positive 17 and a positive 2 give me 19 before I do any movement across the equal sign. Now, they didn't show everything, the steps, but this is adding 4x to both sides to get that 6x. This is canceled out. The 1 is subtracted on this side, so if I subtract a 1, then that's where we get the 18. And then your last thing when you're trying to isolate a variable is division. So you're dividing by 6, which gives me x equals 3. So yes, some steps were skipped here, and I tried to fill them in for you. This one, you want to isolate the x. Draw your imaginary line in your equals, but you do want to make sure that this is moved away from your x first. So we're adding 7 to both sides. After the addition of 7, that goes away. Then we can say, let's take this and make its multiply by its reciprocal. And when you multiply on one, multiply on the other side the same thing, your 9s go away and your 4s go away, so that you're left with just x. I didn't do this step. I don't have it just as a 4 I don't know what they did there. Anyway, you would multiply 28 times 9 and divide by 4, and it should give you 63. So the biggest obstacle with a lot of students is they don't know what to do with a fraction. Just make sure if you flip it, the 9's go away, the 4's go away, you're left with just your x. But whatever you multiply to this side, multiply to the other side. Okay, a couple more questions in review. We did one like this in our last topic where we're trying to find out an average score that we want it to be equal to 438. So if her scores for 3 video games were this, what would she have to score on the next game to tie her friend Ann's average score of 436? Tying it would have to be equal to it. So we're not doing an inequality here, it's an equal. So setting up as a expression, here's the next game. The score on the next game is our value of S. So with that, we don't know. Let's get rid of our fraction. Just like in number 11, you multiply by 4. You can put 4 over 1 if you want. Multiply by 4 on both sides. I've balanced out my equation. The 4's go away. So you're left with adding up your numbers and plus the s that we don't know, and then multiplying 438 times 4. Here you're going to subtract. I need to show it. I probably shouldn't have put a line under it. It's not division. You're subtracting 1,354 from both sides. So if you want to put a line anywhere, it should be underneath, because this goes to 0. And the subtraction leaves you with that she would have to score, her score average, her score on that game would have to be 398. Okay, here's another one that you have to come up with the expression. Renee earns a salary of $220 per week. So that's just a set amount. It doesn't change. She also receives 15% bonus on her total sales. Well, give total sales the value of a variable, and if she earns 15%, all we did was change this to a decimal by moving it 2 places to the left and setting it, how much would her total sales have to be if she wanted to make at least, here's my inequality, could she make more? This is her $220 that she makes per week, plus her commission of her total sales, so it could be more. So we could say that all of this value could be greater than, but it has to be at least equal to. Subtract 220 on both sides and divide by 0.015. And you would get that her total sales would have to be at least $7,000 for her to make $325 per week. And that's it for 3-1.